All right, here we go. Continuing on with some trig. This is a little bit more practical, and it's going to combine some things that we've done before with some of the new stuff that we learned about trig. So let's just start right off with an example. Start off with a bang. So I'm going to make a pentagon. Not just any old pentagon, but what do you think is special about this particular?
It's a large.
Okay, it's equilateral, that's true, but we have another name for it. It's not just equilateral, it's also what? Equiangular. And what do we call something that's equilateral and equiangular? It's regular. Okay, it's a regular. All right, so let me put a point right there at the center of this. And then we're good to go. So here's what they're going to ask you to do. They're going to ask you to find the area of this pentagon. It's been a while. I don't know if you remember or not, but do you remember how to find the area of a regular polygon? We had a formula. It's actually a pretty simple formula. Area equals, it's 1/2. What'd you say? No, it's not base times height. I'll write it down. All right. Do you remember that one? Do you remember what these letters stand for? The P is the easiest one. What's the P? The perimeter. Yeah. What's the A? That's apothem. Very good. Okay, it's called the apothem. So, well, you know what the perimeter means, right? So if I give you one of these sides, how do you find the perimeter of that? Add them all up, or since it's regular, just multiply it, in this case, by 5, because it's a pentagon, right? All right, so that's how you find the perimeter, pretty easy. What's the apothem? Which one is the apothem? It's a line. Which line? It's a lot of lines. From the center to where? That's the apothem? Straight down. Is that what you want to say? Thank you. Perpendicular. Very good. All right, so that right there is the apothem. We good? And you know how to find the perimeter. Take that, and there you go. So the numbers they give you. Now, the thing is, before, they would make it, I don't know if easy, but kind of easy to do that. Usually they'd probably give you the apothem, then give you one of the sides, and what'd you have to do? All you had to do was take one of the sides, multiply it by how many sides you have, then multiply it by apothem, and that was a piece of cake. No big deal. And then they mixed it up a little bit. Sometimes they'd tell you the perimeter, and you'd have to find the apothem. Sometimes I think they used a hexagon. I think we did this with a hexagon, and you could always find the angle in here. Anyway, they kind of made it easy for you, all right? Easier than it's going to be now. So let's put some stuff that they tell you. They only tell you one thing. They only tell you one of the sides of the pentagon. That's all they tell you. Now, before today, when we first studied this stuff, if all I gave you was one side, there was no way you could have found the area of that thing, okay, because there was too many unknowns. But now we know a little trig, and we should be able to do that for us, okay? So they tell you, it's a weird number, 921 feet. That's 921. I think, if you look in the book, I think that may possibly be the actual measurements of the Pentagon in where? Where's a building, the Pentagon? Washington, D.C. Yeah. I think that's what it is, okay? So you can correct me if I'm wrong, but I think one of these sides, I don't have the book in front of me, but there is a little picture of the Pentagon in D.C., and since they made the 921, I kind of think that that's what they're giving you, all right? Okay. So what we want to do is find the area. Okay, so everything in here. So it's 1/2 the apothem times the perimeter. So what's the easiest thing? We can find something right away pretty easy. What can we find? The perimeter. So let's do that. Okay, so the perimeter would be what? 5 what? Times 921. All right, I've already done that work for you, and that is 4605. 4605, and it's feet. All right, so this is feet, and this is feet. All right, so that's our perimeter. So now, really, that was super easy. So basically, all I got to do is find the what? Find the apothem. So how do I find the apothem? Good question. All right, well, we are in trig, and we are using what kind of triangles? So let's figure out how we're going to get a right triangle out of this. Center. To the vertex. Exactly right. Okay? And we could have done it anywhere, right? And you could always made your apothem here if you wanted to, right? But since we have our apothem, like you said, straight down or perpendicular, we're just going to make that right to there. Or you could have taken it to there. Would it make any difference? No. So it just looks a little nicer if you do it right there. So that's where I'm going to do that. So I made a nice right triangle. Well, there is something I can find pretty easy without doing any trig. There is one thing of this right triangle that I can find. Half the bottom, exactly right. Okay, so if this only, man, I got something in my throat. Sorry. If this is not a regular polygon, then it would not be half. But since it's regular, that apothem does hit it at its midpoint. Okay, so half of 46 point, I'm sorry, not 46.4, half of 921. This is kind of weird because the number kind of looks the same as this. I don't know if that is on purpose or what. I don't know. But it's 460.5. Right, that's half of 921. Okay? All right, so that's that length right there. Well, I don't know the rate. We'll call this the radius, right, of our pentagon. We don't know the radius. Don't know the apothem. I know one side. I don't know any angles. Is there any way to find anything right now? The what of the right angle? Can't find anything?
Well, you probably can.
Yeah, you probably can, right?
Well, you can find the what's it called, the adjacent hypotenuse cosine. You like the cosine.
Cosine of what?
The right angle.
No, you don't do that. You can't do the cosine of the right angle. You can only do the cosine of the other two acute angles. So that's our problem. Don't know either one of those acute angles, do we? But can you find it?
Well, if you find the angles, right, then you can like.
If you find the angles, exactly right. So how do we find the angle?
You divide by.
Find the central angle. That's good. I like that. Using vocab that we've been doing in here. Find the central angle. So let's find that angle right there. So we should be able to find that angle. We've done that not that long ago. It seems like, I don't know, maybe it was my other class I did this. But you should be able to find that angle right there. Remember, it's a regular pentagon.
360 divided by 5.
Very good. All right, because if you go all the way around, that's 360. Agreed? It's evenly distributed amongst 5 different angles, right? Because if I put a line here, here, and here, you'd have 5 of those same exact angles. So you take 360 and you divide it by 5, and that is 72. Okay? So this big angle right there is 72 degrees. That's right. Well, we're just concerned about this right triangle, aren't we? So I just want to find this little one on top here. And you're right. This actually bisects, that apothem bisects that angle, that central angle. So what's this angle right here? That's 36 degrees. So now, Zion, you were onto it. You wanted to do like opposite over adjacent and opposite over hypotenuse, blah, all that kind of stuff, right? But we didn't have an angle before. But now we do have an angle. We got a 36 degrees. So let's make this look a little bit neater. You probably would be fine the way it is, but I like to do this. I just like to draw it so I don't have any of the other junk in the way. Is that all right? So what do we know on this triangle? All I'm doing is just blowing this big triangle up. So what's this bottom? 460.5. What's this angle up here? 36 degrees. And what are we trying to find? What are we trying to find? The apothem. And this up and down one is the apothem, that perpendicular one. Okay? Everybody with me? So really, all this big problem of area basically boils down to this. Because the perimeter was no big deal. Everybody figured that out, right? It's just the apothem that we had to find. So we had to go through all this stuff. We had to remember a few things that we've learned in the past. And now I can actually put my trig to work. All right, so which one am I going to use? Cosine? All right. Why cosine? Because it's... Yeah. Because I don't know the hypotenuse, do I? Because cosine has hypotenuse in it. Sine also has what? Hypotenuse in it. But what do I have here? I have opposite and I have adjacent. Which one uses that? The tangent. All right, so this is the tangent of that angle. So the tangent, and Simone, you were going to find this angle down here, and you could if you wanted to, right? If you wanted to do that, you could have, and you could have gone, this is the opposite, and this is the adjacent, all right? That would have been fine, but it doesn't matter. You didn't have to find this angle, all right? So this is the angle that we found. Let's just use this angle, right? But you could have gone 90 minus 36, which is what? 54? So you could have used 54 right here. Either way, it still gives you the same exact answer. But let's use the one they gave us, or the one that we figured out. So the tangent of 36 is equal to opposite over adjacent. Which one is opposite? 460.5, and adjacent is A. The A is not really for adjacent. What's the A for? Apothem. All right, so what's the math? The math's not real hard here, but I don't want the A on the bottom, do I? I want the A on the top. So I want to take this A and put it over here. How do I do that? Multiply it. So let's see if we can do this in our head, all right? We did this before when we first taught this. We did one where we had the variable in the bottom, but let's just kind of do this in our head. So what am I going to do? I'm going to take this, I'm going to move it over here. It's going to go on the top, right? Then I'm going to take my tangent of 36 and do what to it? Divide it, and it's going to go where? On the bottom. Everybody see that? All right, so you should just be able to do this right away without even putting like times A divided by tangent of 36. Let's just do it in our head. This goes to the left, so that's an A. We're going to get rid of the tangent of 36, so we divide it. So what do we have? We got 460.5 divided by what? Tangent of 36. Yeah, it'd have been a little easier, but really, it's not that big of a deal. I mean, you can just do this in your head, though, now, can't you? So yeah, technically, it is like 2 steps, but this would have been a second step, right? This would have been, so really, the number of steps is the same, just depends which one steps you like better, all right? So yeah, you could take that from 90, you could find that, and then the A is already on the top, right? Because opposite over adjacent. The A is already on the top, so all you had to do is get rid of the tangent, all right? But doing it in your head, it's just, to me, to me because I've done it a lot, but for you guys, you're going to find the more you do this, it's just as easy setting it up like that, right? So that's my apothem. So here's something that you got to be careful of. I'd probably give you credit for this, but when I did this, I actually figured out what the apothem was and got a decimal. So I took this and I put it into my calculator. You know it's going to be an approximation because the tangent of 36, right, is going to be some crazy decimal, so I round it and then I divide it, and my apothem came out to be 633.8. Okay? Everybody with me? So I just stuck that in a calculator and I got this. It's approximately equal to that. So now I want to find the area. The area is what? 1/2 the apothem times the perimeter. So it's what? 1/2 of what? 633.8 times the perimeter. Do you remember what the perimeter was? It's up here, 4605. 46. And the 4605 is exact, right? There was no approximation with that. So when I put that into a calculator, I get this big old number. I get 1,459,324.5. And it is area, and it's in feet, so it's what? Square feet. So that's what I got. And that's perfectly fine. But the book gives you a little bit of a different answer. It's pretty close, but it's a little bit far, all right, depending on your view of what's close and what's not close. What they did was this. Instead of rounding it here and then multiplying it, what they did is this. They put 1/2. What was the apothem? The apothem was this. So instead of rounding it and then multiplying it, they did this. They put this whole thing. So when you put this into your calculator, this goes out a whole lot of decimal places. It goes like 7 or 8 decimal places. You follow me on that? So this, I rounded it to 1 decimal place. This, it goes out like 7 or 8 decimal places, all right? And times what? 4605. Actually, I have to look at the book because I didn't write down what they wrote down as an answer. So here's what I'm going to put it down here. So they wrote 1 and then 459, so that stays the same. And 379. 9. And they didn't round it. They just kept it like that. So if we would have rounded this, it would be 325, right? So we got 325. They got 379. Does that mean that our problem is wrong? No, it's just because of the way that we rounded, right? See, we rounded this number, which is going to round our answer. This one really, well, technically it is rounded, but it's rounded to like, 7 decimal places, okay? So you're going to get a little different number, aren't you? Right? That when you multiply all that stuff together, and you do. So either way, if you would have gotten this answer, I would have given it to you. If you would have got this answer right here, and this is the way the book did it, okay, that would have been fine as well. All right, so we just did that little intermediate calculator work, and then we did it more calculator work. Right here, you just put everything in the calculator all at one time. And it is more accurate. Okay, this is definitely more accurate than this. So this is closer to what the square footage is for the Pentagon than this is. You okay with that? And you look at it, you're like, man, that's not even close. Mr. Hammer, that's like, 55 square feet off, right? But when you compare that to almost 1.5 million, is 55 really significant? No, not really, okay? But technically, that is more accurate. Make sense? All right, let's do another one. Let's do a triangle this time. So what is you should know the area of a triangle. What's that? Very good. So do about like this, do about like this. So this is not this is not a regular triangle, it's not equilateral, it's not equiangular. And I'm going to, what is that line right there? Why did I put that line there? It's the height of it. Good. Come on. There we go. All right, and here's what they tell you. They give you a picture. If you look in the book, they give you a picture and they talk about it and stuff, but it basically boils down to this. They tell you that come on, let's try it again. There we go. That side is 80, this side is 90, it says this side is 110. I believe what they say is the angle between the two largest sides, all right? So what if I said, what is the angle between the two largest sides? What angle is that? Is it the left one, the top one, or the right one? The right one, yeah. So they tell you that angle, and they tell you it's 46 degrees. So that's all the stuff they tell you, and that's it, okay? And you want to find the what of the triangle? Area. All right, so the area of a triangle is 1/2 the base times the height. Right, no big deal, right? This is what would we say this blue one was? The height. What's the base? It's 110. The base goes from here all the way to here. Everybody good? All right, so we know the base. That's easy. Just plug that in, right? So really, what's the work? To find the height, correct? What is the height to the base? The height and the base always have to be what to each other? Perpendicular to each other. So what kind of angle do we have here? Right angle. So we have a what? Right triangle. And if you wanted to, you could draw it separately. I don't know if that's really needed right now because there's not a whole lot of junk around this. Would you agree? So now, this is something that we could have not done before when we first learned how to find the area of a triangle. All right, because we don't know enough stuff. All right, we couldn't do Pythagorean theorem. You just don't know, right? You don't know. Does this split this in half? No, it doesn't, okay, because it's not a regular triangle. If it was regular, then it would, but it's not. So you can't, okay? So it would be impossible with the knowledge that we had back when we did the area stuff. Forget what chapter that was, but whenever we did that, you wouldn't be able to do it. But now you can, because now we can find the height if you know that angle right there. So what are we going to use? We're going to use this one, and are we going to use the 110? No, because the 110's not from here to here, is it? So what are we going to use? The height and the, what other side? Which one? Yeah, the hypotenuse, the 90, okay? So what do I have? What is h to the 46? It's opposite. What is 90? Hypotenuse. Which one uses opposite and hypotenuse? The sine, all right? So that's what we're going to do. We're going to take the sine of this angle, which is 46, equals the opposite, which is h, over the hypotenuse, which is 90. Now this one comes out kind of nice, right, because the h is already on top. But even if it was on the bottom, even if we did something where it was on the bottom, it really wouldn't be that big of a deal. All right, so what do we do here to get h by itself? What math do we do? Times it by 90. So I'm going to do this. I'm going to put it right in front. That's how we show multiplication. You don't have to put it in parentheses. You just put it right in front. Okay, don't put it to the right of it. Okay, put it in front of the sign. That means 90 times the sine of 46. Does that make sense? All right. And now you just plug that into a calculator. Now, again, if you plug this into a calculator right now, you're going to get a decimal approximation. And then we got to take that and multiply it by the base and 1/2. So we're going to get a big, big approximation. So let's compare the numbers again. Let's do it. So when I did it, I actually put this into a calculator. So when I put that into a calculator, I get approximately 64.7 if I round it to one place. Okay? Now, if we find the area, so what's the area? It's 1/2. The base, what's the base? 110 times the height, which is found at 46.7. Again, this is an approximation, but when I get my answer, I get 3558, 3558, and I rounded it to one decimal place, and it's 0.5, and it's square feet. So that's what I got. But the book got something slightly different. All right? And why do you think that is? We just discussed it on the last one. They did it all at once. That's right. So basically, let me scooch this down. Basically, they did this. They took that and they put it here. Instead of making it 64.7, they put it all into the calculator all at once. All right, so let's just write it down. So area equals what? 1/2 of 110 times the 90 sine of 46. So this is what the book did, and this is probably the better way to do it, okay? I'm not saying that this is the better way to do it. This probably is, right here, the best way to do it. And they got, let me see what they got, because I didn't write it down. They got 3560, which is pretty close, right? 3560.7, and that's feet squared. Now, if you did this, would I mark it wrong? No, because it's just a matter of decimal approximations, okay? But this is a little more accurate. It's pretty close, right? Do you agree? It's less than, 2 feet off, but, well, it's actually a little bit more than 2 feet off. But again, when you're dealing with 3,500 square feet, 2 feet is pretty insignificant. Would you agree? Yeah. But this is, if you had to be exact, well, this isn't really exact either, right? Because this is only as far as your calculator will take you, right? If you had a computer that will take you out 1,000 decimal places, this number will be a little bit different, right? So it all depends on how accurate you need to be. And most of the time in real life situations, you don't have to be accurate to 7, 8 decimal places. You might be fine with 1 decimal or 2 decimal places. So it might have been perfectly fine to leave it like this, all right? Just depending on what kind of work you're doing. Everybody got it? All right, enough of that. Now, let's do this. I don't have these formulas memorized, okay? So if I can't remember, I'd have to look at the test that I gave last year. Can't remember if I gave you these formulas or not, but I probably did. And if I didn't, I'll probably give it to you because I don't even have them memorized. Because we so rarely get to this point, and usually it's only my honors class that would get to this point. And some years we don't even get to the trig. But last year we did, and this year we are. So that's good. Good for you guys that we made it this far. So what I'm going to do is give you 2 formulas for the area of a triangle. Area of a triangle. Well, Mr. Hamrick, I thought you already gave us a formula for area of a triangle. All right? But this will be a little more streamlined, a little bit easier to use. All right? So here we go. So if I had a triangle, I'm not even going to draw let's just draw a triangle. Just any old random triangle. Okay? So we'll kind of make it look like the other one we just did. And if I said that this is A, B, and C, what would I call this side over here, BC? Instead of calling it BC, what could I call it? Side A. That's right, little a. And then this one down here, little b, and this one, little c. Everybody with me? All right, so if I wanted to find the area of this triangle, instead of drawing the height, trying to figure out if I use sine, cosine, or tangent, instead of doing all that stuff, they kind of streamlined it a little bit. Hunter, you getting all this, are you? So here we go. The area of a triangle is this. It's 1/2, okay, so it starts off pretty much the same. Watch, BC times the sine of A, or I could go 1/2. Now watch this. See this BC? And see how this is angle A and we use the other two sides? So what if I use angle B? What if I say the sine of B? What would I put here? A and C, good. All right, and then I go 1/2. Let's do the rest. What would I do? Sine of what? C, so what would this be? A and B. That's probably not that hard to memorize, is it? All right, so it's just kind of nice. Let me see something here. Yeah. So let's go back to that other example that we just did. Like this one right here. All right. If I use this one, okay, if I use this angle, guess what side I'm not going to use? The 80, right? So if this was angle C, right? So what would it be? If this was angle C, this was side C, it doesn't matter what these are. Let's call this A and B, all right? I already got a B here. That was for base, but that's okay. We'll call it B. So how would I use that formula that we just went over? The area is equal to, what am I going to do? I'm going to take the sine of 46, correct? And then multiply it by the other two sides, not the 80, not the one that's across from it, but the other two. What would that be? 90 and what? 110. Oops, forgot the half there, didn't I? Scooch that over and put 1/2. Would you agree that that's what that formula tells us we can do? Yeah, absolutely. So look, we didn't have to draw this. We didn't have to go, I wonder which trig function we use. It really wasn't that difficult to do it. And look, and you didn't have to like put it back into the 1/2 base times height formula. You didn't have to do all that stuff. It's all streamlined. It's right there for you. You put that all into the calculator. Is it the same thing that we got when we did it the old-fashioned way, we'll call it? Yeah. There's my 1/2. There's my 110. There's my 90. There's my sine of 46. Isn't that cool? All right. So now we can find the area of a triangle if they give you 3 sides. Well, actually, you don't even need 3 sides. They don't even have to give you that, did they? All right. So if you get 2 sides and an included angle, what do we call that? Side, angle, side, right? If they give you 2 sides and an included angle, you should be able to use this formula right here. So they call this the side, angle, side area theorem. Side, angle, side area theorem. Okay? Does that make sense? So if you have a triangle and you know a side and the angle in between, you should be able to find the area of it very easily with this formula right here. And what does this mean? Do you have to memorize like all 3 of these? No. Basically what it means is if you know the angle in between, right, you just take the sine of it and multiply it by the other 2 sides, right? Not the A side, it's the B and the C. And then you take half of it because it is a triangle. Make sense? Yeah, that's kind of cool. I like that. Makes things a little bit easier, right? I still could have done it the other way, but it makes it a little bit easier. We got one more to do. This is if they give you all 3 sides of a triangle. Okay, so if they give you all 3 sides and no angles, they don't give you any angles at all, okay, and just the 3 sides, here's a formula on how you do it. And it's such a special formula, it's named after somebody, and I don't know any of the history whatsoever about this person's name. I guess it's a guy, I don't know. Could be a woman, all right, but we'll call it the side area theorem. Again, this is a triangle because you got 3 sides, right? Side, side, side. Everybody with me? But they give it this person's name. You can look it up if you want. I haven't done it yet, but they call it Heron's formula. Again, I don't know any of the history of this person or how they came up with this or anything. This is one that I don't know if I would, I mean, I guess I could memorize it, but I don't like have it memorized right now. If you would have stopped me in the hallway today and say, hey, could you give me Heron's formula? I wouldn't be able to do it. But if I'm studying it, right, maybe after today, if I did a bunch of problems using it, maybe I would have it. So here we go. So the area. This is area of a triangle. All right. So again, this is just a triangle. So the area of a triangle is equal to this. It's a big old square root. I'm going to use the letter S. The letter S represents, I'll put equals. It's the semi, this is weird, but this is the semi perimeter. That's why they use S for semi. Now remember, if I know all three sides of the triangle, I can easily find the perimeter. How do I do that if I know all three sides of the triangle? I add them all up. But what's the semi-perimeter, do you think? 2/3 for semi? What's a semicircle? Half a circle, right? So what's a semi-perimeter or semi-perimeter? Half the perimeter, exactly. So I'll just do this. I did put this in my notes. It's probably in the book. So what's a semi-perimeter? It's half of all the sides added up. And I'm using A, B, and C, so what are all my sides? A plus B plus C. That's what S is. So you're going to see a bunch of S's up here, right? So what's the first thing you're going to do? You're going to find the semi-perimeter first, okay? Half of the perimeter. Everybody got it? So you add them all up, divide it by 2, and then you're going to put it into this formula. So you're going to go the side, or the semi-perimeter, times S minus A. This is actually pretty easy now I think about it, but I just didn't remember it. And then S minus C. There it is. So that's how you find the area of a triangle if all you know are all three sides. You don't know any angles whatsoever. So this really doesn't even look like trig, does it? All right? It's just messing with the sides. Let's do an example. I've got 5 minutes, so let's do a couple examples. You got that written down? So really, that's not that hard, is it? It's the side times the side minus one side. Not the side. It's not side. What is it? Semi-perimeter, okay? So minus A minus B minus C, multiply them, take the square root, and you're like, who came up with that theorem, okay? I'm sure there's proofs of it. You could probably look it up. Go on YouTube, put in Heron's formula, and there's going to be tons of people that love to show how smart they are and how to get that theorem. I'm sure you won't do that. I'm sure you don't care, but, you know, whatever. I think it's kind of interesting to find out where these come from. All right, so they give you this as 5, and they give you this as 4, and they give you this as 75. So which one of the two are we going to use to find the area of that triangle? The side angle side one, okay? And what was that? That was the 1/2 BC and all that kind of stuff. So we'll call this A. We'll call this B. We'll call this C. All right? So let's write down the formula. We don't have to write all three of them, just the one that applies here. So what is it? It's 1/2 of what? BC times the what? The sine of A. So now, you don't have to, draw the height. You don't have to look at it and say what over what and what trig function and all that kind of stuff. All right? It's going to be the sine. And so all you do is just plug everything in. Just plug and chug, right? So it's 1/2 times B, which is 5, times C, which is 4, times the sine of A, which is 75. Throw all that into your calculator all at once. I would put it in all at once, and you're going to get approximately, I shouldn't put equals here, technically, it's approximately 9.7. And this one's in meters. I didn't put it, but it's in meters, so it's meters squared. It's that easy. Simple, isn't it? Yeah, you don't have to draw the height. You don't have to think about it. You don't have to say what over what, all that kind of thing. You don't have to do any algebra with it. It's just all there for you. It's in a nice little package, and boom, you just stick the numbers in, and you're good to go. Aren't they nice to do that for you? Absolutely. One more, and we'll be done. So what if I gave you like this, and like this? And I tell you, one side is 10, the other is 7, and the other is 9. It's not exactly drawn to scale, but who cares? You care? All right. So I want to find the area of this. I don't know any angles. There is no way in the world we could have found the area of this before, right? Because if you put the height, you just wouldn't know what the angle was, right? It'd be impossible. But with this formula, with Heron's formula, you can find the area of this triangle, which is kind of interesting. So first of all, let's write down the formula. I probably have it memorized now, don't you? Big old square root. What's first? S, and then S minus what? A, which just means one of the sides, right? And then S minus one of the other sides, and S minus the third side. So you do have it memorized, don't you? Yes, pretty easy. What's the first thing we need to do? Find what? Find S. All right? So how do I find S? It's half of the perimeter. So how do I find the perimeter? Add them all up. Okay? And I get 13. That's 26. Take half of 26 and it's 13. Now I'm ready to apply the formula. So big old square root S, which is 13. And then S minus one of the sides. It doesn't matter which one. So it's 13 minus what? 10. All right? Times 13 minus, let's go biggest to smallest, 9. And then 13 minus 7. All right? You put that all into your calculator and you get the square root of 936. Okay? This is all calculator work here. And that's approximately 30.6. It is area. This is in inches. So this is inches squared. And there you go. Again, two nice little packages all tied up with a nice little bow on top of it. It's your little Christmas present in May. All right? And that's how you do them. Everybody good? It's pretty easy, wasn't it? Yeah. We could have probably just done this. Would you agree? I probably could have just started today and said, all right, this is how you find an area of a triangle. But we kind of did it the old-fashioned way. See that? Well, this isn't a triangle, but we kind of went the old-fashioned way right here. And then there's an easier way to do it, so there you go. Your homework is, now that I'm thinking about it, I think you can memorize that. Yeah.
No, what's the homework?
I'll give it to you. It's on your, yeah, it's on your lesson plan.
I don't have a lesson.
5 to 18.
On what?
That's not that many. It's what, 14 problems. So number 5 to 18, and it's section 12.3. That is your homework.